Okay, so in this video we're focusing mostly on radical functions, but before we do that, we're going to talk about the idea of a parent function and how do we transform a parent function into what I call the child function. So in general, the graph of the parent function typically starts at the origin, which is 0, 0 on the coordinate plane. However, as we've already seen, when we graph any function, they can be located anywhere on the coordinate plane, they can be stretched or shrunk, or they can be reflected. This process of altering the parent function is called transforming graphs. And in general, the graph of the parent radical function is given by y equals a times the nth root of x, where n is the index of the root. Could be even, could be odd. This graph always starts at the origin and always passes through the point 1, comma a. So here a tells us what point we're going to go through, and it also tells us how wide or how skinny the graph is going to be. The transformed graph of the child radical function is given by y equals a times the nth root of x minus h, and then plus k. To graph this function, it might seem a little hard, but all we need to do is start off by graphing the parent function, y equals a times the nth root of x. Then all we do is shift that parent function h units horizontally and k units vertically. So in example 20, let's start off by doing that. Then we're going to talk about the domain and range. Okay, so here in blue is the parent function, in red is the child function. I've actually already graphed those. But let's talk about how does the child function that we have in example 20 match up with our model. So here's the model for the child function. In example 20, I have y equals negative 3 square root of x minus 2 plus 1. Based on the model, that means that a is negative 3, h is 2, and k is 1. Alright, well, again, blue is the parent function. We know the parent function for radical functions always goes through 0, 0 and the point 1, comma a. So on this graph, it's going to be 1, comma negative 3 because that's our a value. That checks out. And to get to our child function, we're told to shift the graph h units horizontally and k units vertically. So I'm going to start at 0, 0, h units horizontally, so that's positive 2, so I go to the right. And then k units vertically, so that's positive 1, so I go up. And I get to 2, 1, exactly like I'm supposed to. Same thing, if I go to the point 1, negative 3 on the parent graph, and I go right 2 and up 1, I get to 3, negative 2, which is exactly where I'm supposed to be on the child function. So everything's checking out based on our information about the child function. Now let's talk about the domain and range. Remember, we typically say the x values are our domain, the y values are our range. To help me out, what I'm going to do is, yeah, it kind of looks, our range is no problem. If we look at the y values, it goes all the way down, keeps falling down as far as it wants to go, all the way to negative infinity, and it's going to keep going up, following the arrowhead, all the way up to positive infinity as high as it goes. There's no restrictions on the range. So I'm going to go ahead and call it a range, all real numbers. Again, we use the fancy double R to represent all real numbers. The domain is a little bit trickier because it looks like there might be a restriction on our domain. It looks like we're just going to hit positive 2 and just kind of stop there, like there's an imaginary wall. So what I'm going to do is I'm going to actually graph this function in my calculator, and I'm going to look at my x values. I'm going to go to my table and look at the x values. If you have anything else in there, clear it out. So y equals negative 3 square root x minus 2 is both underneath the radical, so it needs to be inside parentheses. And when you're done with the minus 2, be sure you close it up. That's very important. Then plus 1. So I'm going to graph, and actually it's supposed to be, yep, okay, so it matches up with our picture, so that's good. I was just double checking, and now let's go to the table. Alright, well, if I go up to 2, I can see that my calculator at 2, there is a y value. However, when I go past 2, I go to 1, 0, there's errors. So that means there is a restriction on the domain. So here that means my domain is valid for anything greater than or equal to 2. That's what it looked like on our graph that we were given. It looks like the domain stopped at 2. Again, domain is our x values. But I wanted to verify that, so I checked it in my calculator. In example 21, we have the graph y equals 3 times the cube root of the quantity x plus 2 minus 1. And then we also want to state the domain and range. Again, The parent function is in blue. We know the parent function always goes to the point 0, 0 and the point 1, comma a. It doesn't matter what our index is. As if it's a radical function, it's always going to do those two things. In red, we have the child function, so that's already graphed for us. What I'm going to do is to use my rule that was on the previous slide and figure out what A, H, and K are and verify that we do have everything we're supposed to. So I know based on the rule my A was positive 3, my H is negative 2, and my K is negative 1. All right, again, if you need to see the rule, look in your notes or just rewind the video a little bit. Here, my parent function does indeed start off at 0, 0, and it goes to the point 1, comma a, because a is positive 3. So everything's checking out the way it should so far. And we know to graph the child function, we just go from any point on our parent function and we shift it h units horizontally and k units vertically. So I'm going to shift h unit, I'm going to start at 0, 0, and go negative 2 units to the left and 1 unit down. And I get to that point I'm supposed to. If I start at positive 1, 3, I'm going to go 2 units to the left and 1 unit down. And I get to that point I'm supposed to. So I can do that from any point on the graph, 2 units left, 1 unit down, and I get to the child function exactly the way I'm supposed to. So I have the correct values for A, H, and K. Now we want to talk about the domain and range. First off, let's look at the domain. Again, we typically think of the domain as our x values, so all I'm looking at is right and left. The graph is going all the way to the left as far as it wants to go. There's no restrictions as we go left. And the graph goes all the way to the right as far as it wants to. There's no restrictions to the right. So the domain is going to be all real numbers. And our range, again, range we typically think of y values, so I'm looking for any restrictions either up or down. The graph goes as far down as it wants to with no problem, and as far up as it wants to with no problem. So the range is also all real values. Or all real numbers, I should say. That's really it. And that's it for this video talking about radical functions. If you got questions, please let me know.